Okay, we're gonna go ahead and try to solve one of these force problems. So it says a 100-pound sled is on a hill at an angle of 41 degrees with the horizontal. Find the force needed to keep the sled from sliding down the hill. So first we need to draw a picture. So we've got this 100-pound sled on a hill at an angle of 41 degrees with horizontal. So if I draw that, I'm going to try to draw it the best I can too, so it actually looks like 41 degrees. So maybe that looks like 41 degrees here with the horizontal. And then I've got to put this sled somewhere on there. It really doesn't matter where, but somewhere on there is the sled. Anytime that we are talking about weight, like this 100 pounds, we draw it as a vector, okay, because it represents a force, and we draw it when we're talking about weight straight down, like think towards the middle of the earth, or like kind of like gravity. What's pulling this down, the whole 100 pounds? And it doesn't really matter how long you make that vector, but make sure it goes past the horizontal here, because that'll help us. So really this is all the information that's given, but what are we trying to find? In the end, they say we want to find the force needed to keep the sled from sliding down the hill. So we need to project this vector back onto the hill. So the 100 pounds back on the hill isn't going to be 100 pounds because we're going to be, like, the earth, the actual hill, is helping me hold that up. We're not holding 100 pounds off the side of a cliff, like straight down like this. So we need to project this vector back onto the hill. Projection means we're going to make a right angle back to the hill from the end of that vector. So what we're actually trying to find is this vector right here. Okay. Why we're trying to find that one is because we're trying to counteract that this way. So this is what's pulling the sled away from me, that much force. We're trying to counteract that force this direction, the same amount, to keep that sled completely stationary. So if we can figure out this, we know how much we need to pull the opposite direction, we know the force we need. So here's kind of the interesting part about this one. We've got a right triangle here in red. What's important is we need to know an angle in there. We know 90 degrees, but we don't know another one. So we do have another right triangle in this picture. This right here is a right triangle. And if you think about that, if this is 90 and that's 41, I can figure out that angle pretty quickly. Just by doing simple subtraction, this angle has to be 49. So they add up to 180. So now I don't need the blue triangle ever again. But if I go back to the red triangle and realize this 49 is also part of the red triangle, I can find the magnitude of that vector, which is what I'm trying to find, that force, just by doing simply cosine. So again, focus in on this triangle right here. This is a right triangle. We've got the hypotenuse of it. We've got the adjacent to the 49, so I can simply do cosine of 49 equals adjacent over the hypotenuse, multiply the 100 over, and just simply type in a calculator 100 times cosine of 49. I get 65.61. And we're talking about force, just like we were talking about the weight being a force, so it's going to be in the same units. So we're talking about pounds. And by the way, I've been abbreviating pounds like that. And if you really think about that, it makes sense because we don't have to hold all the sled's force up. It's helping us some. But we're at a decently steep angle, so it makes sense that I'd have to have slightly more than half of it that I'm holding up. Hope that helps.